A generator with a square-shaped coil is rotating in a uniform magnetic field. The coil has 140 turns. The magnetic field has magnitude 0.12 Tesla. One side of each square loop measures 1.5 centimeters. And the maximum value of the induced EMF is 27 millivolts. Now, why do we say maximum EMF? Because in a setup like this, the EMF induced will change with time. The question is, what is the angular speed of the rotating coil? Let's start with Faraday's law. The magnitude of the induced EMF is equal to N times d phi dt, N being the number of turns, and d phi dt is the time rate of change of the magnetic flux. Now, what is the formula for magnetic flux? It's B times A times cosine theta. B is the magnetic field magnitude, A is the loop area, and theta is the angle between the magnetic field vector and the area vector for the coil. Now, as the coil rotates, theta changes. So the quantity that changes with time here is cosine theta. So we can pull B and A outside of the derivative term. So what is this equal to? It's equal to N times B times A times the time derivative of cosine theta. The derivative of cosine theta is negative sine theta. Because I have an absolute value sign on the left hand side, because I'm looking for the magnitude of the EMF, I'm going to omit the negative sign. So then I'll have sine theta times d theta dt, like so. So sine theta times the time derivative of theta, which is the angular speed, basically with a positive sign. So then this is the quantity I'm looking for, the angular speed at which the coil is rotating. So now we have an expression for the magnitude of the EMF, and we can see that it changes with time because theta changes with time. Since theta changes with time, sine theta will change with time. So the EMF changes sinusoidally with time because it depends on sine theta. Now we are given the value for the maximum EMF. Now if you look at the right hand side of this equation, what makes this expression maximum? Well, when sine theta is at its maximum value, then the EMF's magnitude is at its maximum value. The largest value sine theta can be equal to is 1. So then the maximum EMF is equal to N times B times A times d theta dt. We rearrange our equation to isolate the angular speed and substitute the numerical values. We get 7.1 radians per second as a result.